So as we just saw, in the case of the Pareto distribution, our Wald's test, right, has the form, basically, we're going to reject the null hypothesis when the Wald's test statistic Tn, right, which we just showed, is greater than or equal to some quantile of the chi-squared 1 distribution, right? And so if we want to do, say, a level 0.05 test, we look at the 95th percentile of the chi-squared 1 distribution. Now, if you look at this up in a table or you calculate it using some software like R, you'll find that this quantile is actually 3.84. Now, the likelihood ratio test uses a different test statistic, Tn prime, which we just showed, and it has the same asymptotic distribution as Tn. So again, we're going to reject at that same quantile level, right? Again, it'll be 3.84. So now let's actually do this test, right, using the values that I gave. So let's say we want to test whether theta equals 2 versus theta not equal 2 in this Pareto distribution. And we suppose we actually observe the MLE is 2.45 with a sample size of n equals 100. So remember, Tn is the sample size n times the Fisher information at the MLE times the MLE minus the null hypothesis value squared. So we can just plug in numbers, right? We can say 100 times 1 over 2.45 squared times 2.45 minus 2 squared, right? And this actually will give you a value of 3.37. So now if we look, does our test accept or reject the null hypothesis? Right? This test will reject when this indicator is 1, when Tn is greater than 3.84. So is 3.37 greater than 3.84? No. So Wald's test fails to reject the null hypothesis H0, that theta equals 2. Now in the other case, let's calculate Tn prime from the likelihood ratio test and see whether or not it actually rejects the null hypothesis. So remember, Tn prime equals 2 times the likelihood, x1 to xn, given theta hat MLE, minus the likelihood x1 to xn, given theta naught. And now quickly, if we're going to actually plug in values in here, right, let's just say, let's write out, for example, what is the likelihood of theta naught, just to show how to do this calculation. And here, let's say theta naught is 2. So we plug in, we're going to get n times the log of theta naught, right from there, plus minus theta naught minus 1 times the sum of the logs, right? Now in this case, I didn't actually give you what the xi values are. I only gave you what the value of the MLE is, okay? But remember that the MLE is n over the sum of the logs. So 1 over the MLE will just be the sum of the logs over n. So what this means is that the sum of the logs, right, this term, equals 1 over the MLE, right? The MLE will give us the sum of the logs over n times n. So now we can just actually plug in values, right? This actually equals n times log theta naught plus minus theta naught minus 1 times n over theta hat MLE. Whether or not you're actually looking at the likelihood of the MLE or theta naught, right? Any value of theta naught can be plugged in here. So now let's actually plug in our values. We have theta hat MLE is 2.45, which you could plug in for theta naught in this expression. You have n equals 100, right? And theta naught will just be 2. So if you actually plug this into your calculator, you'll find that Tn prime is 3.85. Now, does the likelihood ratio test accept or reject the null hypothesis at the significance level of 0.05? Well, again, we have to look at whether or not Tn prime is greater than or equal to 3.84. We see that it actually is. So the likelihood ratio test rejects H0. Okay, so we have two different asymptotic chi-square tests, the Wald's test and the likelihood ratio test, which actually can give you different answers. These are both tests based on the MLE and both have, the same asymptotic distribution. And so it might be surprising to you to actually see that they are giving you different answers. But at the same time, they're very different tests based on different asymptotics. And so in the actual finite sample regime, right, these approximations between the two may not be as good for one versus the other. And so you could actually expect them to give you different answers like this. Okay? So hopefully you learned something about the maximum likelihood estimator based tests. Wald's test and likelihood ratio tests, they're both very useful. And you can use this as a framework to guide your own hypothesis testing questions.